Hello, I hope everyone is doing well. I am looking to start a YouTube course on thermodynamics and statistical mechanics, specifically statistical mechanics. This is a topic I find incredibly fascinating. It's something that we interact with all the time. It is essentially physics, but we are trying to look at physics through heat transfer or energy transfer, through temperature, through like macro systems in a way. And so, some a general overview on this. The first part would be thermodynamics slash kinetic theory. So that'd be like heat transfer through convection, conduction, radiation, specifically radiation, I really enjoy. Laws of thermodynamics, from the second law being entropy to more the classical gases and beyond, just classical thermodynamics in general. Then from there, we'll be looking into statistical mechanics, which would be like deriving the thermodynamic laws, the canonical ensemble, the partition function, the chemical potential, and more. And speaking about and more, then I'd be looking potentially to go further into things like renormalization group or the Ising model, or talk even more so about scale variance or scale invariance, so getting smaller or larger to macro to micro systems in physics and beyond. Um, so, some of the topics of major interest would be like radiation and temperature. I particularly enjoy radiation, so I will probably do a bit on that. I will probably move about throughout the topic quite a bit and go into different areas. I'm probably going to try to stay relatively on track, but it will be more so on interest, what seems to be interesting, um, and just what seems fun, I guess. Some other areas will just be like example problems. That's probably always useful for everyone, and to relate with other topics in physics. So each topic in physics, the major ones, whether it's classical mechanics, your electrodynamics, your stats mech, your statistical mechanics, your quantum mechanics, and beyond, they all of them do not happen independently of each other. In fact, they're all happening all the time, all at once. Um, it's everywhere, almost there. Yeah, so on. I think you get the point. So potentially relating to other topics might be of interest and might just be quite fun. But we're looking at talking a little bit more on this. So thermodynamics versus stats mech. So what's the big difference between the two? Well, thermodynamics are going to be macro system, so about equal or larger to human scale. So things that we could see, things that we can feel, like temperature, and more. The laws of thermodynamics. Something to note about thermodynamics is that it was discovered experimentally. So it's been postulated, not really explained, until we get to stats mech, statistical mechanics. And before we do that, what does statistical mechanics mean? Like, why statistics and mechanics? Well, mechanics because it's moving, and going about. But why, like, statistics? Statistical because we are taking many particles and finding out what do they do, like on average, in a way, like statistically, in a way. So when we look at microsystems, but we want to have a lot of particles, like 10 to the power of 20, or more. And what's that's going to look like? From there, we will also like derive the thermodynamics laws, and also we'll talk more about uh, what particles obey by from the laws of mechanics. So classical quantum, Newtonian, relativistic, relative or relativistic quantum mechanics, even more fun. And from there, we'll talk about, the emergent properties. So like emergent properties, which is going to be like temperature, entropy, heat, and those are defined based off particle variables such as position, velocity of particles. And we'll further cover a bit more on this. To talk a bit more on the scale part, for matter, we're looking at about 10 to the power of 20 or more particles. It could also be less potentially, but it works particularly well for 10 to the power of 20 or more. But this can even go down to like 10 to the power of 2 or 10 to the power of 3. But it doesn't, that would be like nanophysics, but it doesn't work as well as really big numbers, like 10 to the power of 20. So you can get the statistics involved in a way. But to put this in perspective, for like computational cost, in my like computational fluid dynamics class, we were talking about fluids that happen in 3 dimensions. And so to give like a little experiment, if you have n to the power of 256 elements, you have that in 3 dimensions, x, y, and z. You put all that, you're going to get 2.8 times 10 to the power of 14 elements. You multiply that by 8 bytes. You're looking at about 2,252 terabytes of information. That's not something you want to put into your computer. It will probably wreck it and then some. So these are like unfathomably large numbers of like 10 to the power of 20. Just to really put that into perspective, it's really large. But anyhow, statistical mechanics is an incredibly interesting subject. I'm very interested, and I am looking forward to exploring it more, as well with anyone who would love to join. Anyhow, thank you, and yeah.